to harness energy, right? So we started with individuals, and then we said individuals were members of populations, and after population, there we go. No, what are you doing? All right, I just have to assure you that I am taking these notes and you'll be able to see them because AirPlay is not being friendly. So we went to individual, then population. And then for population, we did community. And then from community, we did ecosystem. And if we add up all the ecosystems, we're in the biosphere. So those are our 5 levels. And I'll tell you guys that we're almost done with ecosystem. I know you're almost done with ecosystem because you have a test on it on Wednesday. But what we talked about was we put it all together. We said that most communities consist of things living together in their ecosystem, and they usually are complicated. They make something like a food web. And then we followed the energy flow, and you guys studied the nutrient cycle through those. And we said we can take all of those members and we could put them into a trophic pyramid, right? That trophic pyramid was the pyramid that we labeled, primary trophic level, secondary trophic level. And we could read that pyramid in a few different ways. One of them is biomass, the amount of living matter. Who has the most? Primary, secondary, tertiary, quaternary? Primary. And we could also interpret it in terms of energy. In which case, who has the most available energy? Primary. How much energy is lost from step to step to step? 90%, so 10% is saved. And then there's a group that we haven't put on there yet, and that's where I need to go today. There's a group that didn't get put in the trophic pyramid. They're heterotrophs. They eat, but they aren't really selective.
Parasites and decomposers?
Parasites, decomposers, right? We don't ever put decomposers in our trophic pyramid. Decomposition has 3 parts. And they're super important parts because there's no way that any of that matter could cycle. Any of that carbon, any of that nitrogen, none of it cycles without a decomposer. So the first part of decomposition is what we call leaching, Leaching. I know, because AirPlay's not playing nicely. So leaching, Leaching. That's when all of the soluble sugars dissolve out of the dead thing. In this case, let's think of the dead thing as a newly fallen autumn leaf. When they first fall off the tree, they're typically a brilliant color, right? They're all kind of meh at this point because all of the things that gave them that brilliant color were water soluble. They hit the ground, it rained, water dissolved all of those pigments out of the leaf. For all other intents and purposes, really, they just kind of like the chemicals that make them brilliant colors decomposed. And, well, when you're not a brilliant color, you're just kind of like, I don't even know what color leaves are. Gross? Is gross a color? Gross sounds like a color.
It's in the 64 box of crayons.
Actually, it's probably in the 96 box of crayons.
What about leaves that are like red and
So what it is the decomposition of the chlorophyll that gives them like that any color that they are. As all the sugars dissolve out of them, they end up turning kind of like brownish, grayish, sludgish in a pile, right? That's after leaching takes place. So all that soluble stuff dissolves out. Step 2. Fragmentation. So it breaks down from one whole thing into lots of itty bitty pieces. This can be either chemical or physical, so it can be done by chemical processes that decompose them. It can be done by bacteria, Or it can be done by our friends, the detritivores, because remember those were our things that feasted on dead stuff. They tore it apart. That's another way that, that happens is it's fragmentation. It gets torn apart. The third step is what we call mineralization. And that's where our friends, especially our friends who had the nutrient cycle of nitrogen, the nitrogen cycle, they could tell us all about how in this last step, nitrogen that was bound up in living things becomes an inorganic form of nitrogen, right? That mineralization process makes the nitrogen inaccessible again.
So what is the definition of mineralization?
Where any of the, for lack of a better, how do you say it? Mineralizations when any of the compounds that are bound in space organic compounds are transformed into inorganic things. So it's when it goes from organic to inorganic. So carbon's going to be lost here, nitrogen's going to be lost here. And that's when we rely on those cycles you guys studied to bring them back into the mix. So without decomposition, all of that material would just kind of like add up, right? I mean, think about it even just in our example of autumn leaves. Do we still have leaves up to our eyeballs outside? How many of you guys raked your leaves into a pile and then left the pile there? What's that pile look like now? Same size, smaller? Smaller. Leaching is clearly taking place. The leaves are likely not whole, so fragmentation has taken place. And a great deal of mineralization has probably taken place. Unless you live places like where I live, in which case we just light our leaves on fire. They immediately no longer take up the amount of space. Nothing like a good leaf fire, right? You guys probably don't know what that smells like, do you? It's not legal to do that in the cities anymore because, well, I don't actually have to elaborate, do I? You know why it's not safe in a city? Yeah, it's usually bad form to catch your neighbor's house on fire. That does not make for good neighbors. That combined with, let's see, your 10% rule. Hey, my 10% rule, what law of thermodynamics governs that? First one, second one? The second one? You said that with such question,
Pretty sure it's second.
Really, I was going to say third one, even though I didn't even talk about it, just to see, if I could get somebody to say it.
Since the fire transfers the energy of the leaves into the air, where does the energy go from there? Because no energy actually dies.
Right, so it's lost as heat, right? Mm-hmm. So out into the environs, which just increases entropy, right? We said entropy's on the rise, so it's lost as heat. Some of us cozy on up to that fire and then use the heat to warm ourselves, but I don't know. They actually warned me on retreat to not catch myself on fire. There's this really nice fireplace at the retreat house, and I was cold, so I just kept creeping closer to it and closer to it. Finally, Mr. Herman and Mr. Sierra were like, if you get any closer, you will melt the clothes to your body. Please don't get any closer. It's unfortunate. We good with this idea? We start with a whole leaf. That's a terrible leaf. Then that whole leaf turns into, I guess it's the closest I'm going to get. Hello? There we go. All the soluble stuff ends up coming out of it. And then it breaks up into little pieces. And then all the stuff that's caught as organic compounds becomes inorganic. So the difference between matter and nutrients and energy in this system is what? seems like there's a distinct difference between nutrients and energy.
Good afternoon, DC. Excuse this late day announcement.